All right, air source heat pump sizing and selection web application. Okay, we're going to talk in large terms. We're going to probably try to run through this as best we can. We're going to run through this with the looking at the challenges with air source heat pump installs. We're going to use the CSA F280 calculations from our first session. We're going to give you an introduction to the web app. We'll throw some slides up as to how we use the web app. And then we'll just wind up with a few key takeaways and discussion. Okay, once we know the F280, okay, we can actually use this app. So this app is predicated on us doing a full, not necessarily a full F280. We can get away with that whole house F280. But again, with the design detail, more is better. It is going to help us out. So what we've done is we've used the F280, we can calculate the heating line, we've overlaid the heat pump capacity curve, we've determined the thermal balance point temperature, and we've right-sized our system to meet the homeowner's needs. So we've established that. So there's a QR code here, and I think Joe's, you did not?
I didn't, I'll hand some out.
All right. Joe will be handing out some QR codes. That'll get you into that app. It is free. You can go into it anytime you desire. And the cool thing about this is that in the second item here is it allows everybody to cooperate together. So builders, HVAC designers, energy advisors can all be part of the conversation and go into the same file and have access to it. Okay, the app integrates different facets of air source heat pump sizing in a mobile-friendly, easy-to-walk-through package. The system sizing and product selection, we talked about that with the F280. It will give you, and what you have seen today on some of those graphs, not the graphs themselves, but the information from those graphs has been generated by this web app. And it will also allow for the different control mechanisms. So if we want to run a few what-if scenarios, this selection tool will help us do that. So the app is a combination of the sizing and selection guide. This is actually a publication from Natural Resources Canada that you can actually get online, which is the best practice for sizing. The sizing and selection tool, which used to be, like I mentioned before, I think this used to be an Excel application. And the master planning and decision guide, which I will spend a little bit of time on. It's something that I'm particularly passionate about. And it also comes with an awful lot of input from industry. So HVAC people, manufacturers, designers have all had impact and input into this tool. So before we start, we need the whole home design and heating and cooling. So as I mentioned before, you don't need the full thing to use this tool. We just need the sizing. So talk to your energy advisor that you're dealing with. Have them run a session on that Volta, and we can start with something like that. We just need the basic heating, cooling loads. And then we also need to understand past issues and goals for the project if this is an existing home. If this is a new home, these really don't apply. And we have to understand the market challenges and what's motivating the client. Again, our case study home. So here's your login page. So you'll sign in or sign up with an account, and you will create a project. And this one, we've already got 3 projects created. Some are in progress, some have, and you can see on the progress bar, we've got 1 of 8 things done, 1 of 13 things done. Now, once we create this project, we have to throw some settings at it and say, what do we want to call the project? Who's the client? What's your role in this? So if it's a builder that's initiating this, the builder puts it in. I'm the home builder. What's your role? I'm the energy advisor. I'm the HVAC designer. And who are the collaborators? So you can add collaborators to this. And this feeds into what we call IDP, integrated design. Okay? So that is basically a builder saying, you know what? Before I design the home, let's have a conversation with everybody about the home. It's a great way. We used to call it a design charrette. when we were first doing the net zero homes. It's getting everybody together and saying, you know what, if we move this wall over here, it can save us this much on flooring. Or if we move this wall over here and make it just 2 inches bigger, now all of a sudden we can run stacks, we can run a plumbing stack for the entire home. Why don't we put these bathrooms back to back, because they're close, but they're not close enough. I want to run everything through the same stack. From an HVAC standpoint, I want to make sure that I have enough room for all my supplies and my cold air return. And that's another thing we're going to talk about in a minute as well. So we can add this and it feeds into that integrated design process. We're going to identify the project itself. Is this a new home? Is it an existing home? Do we have a new system installation, or are we dealing with existing ducting? And where's the location? So we want to be able to add things like cost of utilities and things like that into it. Okay? And also, you know, for the greenhouse gases, they'll use the wrong Alberta one for now, but I'm pretty confident they'll fix it. Okay? And then project details. You know, we always say the devil's in the details. So here you can kind of identify what challenges you're trying to overcome. All right, and it'll help you, you know, kind of keep your focus as you go throughout this process. And here we are on step 2. And so this is the air source heat pump unit configuration. Are we using a centrally ducted system, which is the most common in Alberta, but we also have options to do ductless mini splits, mini split multi-zones, and a ducted mini split. So we can actually do a combination of, like, not only zoning, but we can actually do room by room zoning if we really wanted to with a ductless system. There's no end to all the varieties you can have as long as you've got the money to spend. So we're going to ask the software, what do we want to throw the emphasis on? Okay, and again in Alberta here we want to throw the emphasis on a balanced cooling and heating. But you know, if we're in you know, southern Ontario, perhaps we want to throw an emphasis on cooling. We don't have a whole lot of heating requirements. Vancouver, Victoria, that sort of thing. Or if we're further up north, we want an emphasis on heating. And then we have a final option here where we have the heat pump as the sole heating source. And as I indicated in the first session, we can actually get into home designs with a program called Passive House, where we drive the heat loads in that home so low that you can actually run a heat pump as the sole heating source. You've got almost no heat loss happening from that house. Now, is that a cost-effective way to build? I don't believe so. I think you can get to net zero for almost the same price. And I think if people had the choice of a super hyper insulated home with almost no heat loss, or a really, really well-built home with some heat loss, but I don't pay any utilities for about the same money, I'm pretty sure I know where people would want to go. It takes a very dedicated and certain individual to run down the path of Passive House, and God bless them for doing it. The supply outlet approach. This is going to be something new for a lot of you guys. We are used to seeing perimeter supplies, right? When we're looking at vents, we always see vents under windows. We always put them there because under the building code, it says that the vent has to be able to wash the window itself. And the purpose of that is to take the humidity off of the window throughout the winter season. Now, we've always done that because that was the kind of system that we had. But there are other delivery systems that allow us to run a central supply, run a high wall delivery system, all right? The great thing about a high wall delivery system is we never have to worry about somebody putting a piece of furniture over the vent.
Or the return air.
Or the return air, either one. But if it's a high wall supply system, we can put, builders, first off, for a builder, you can design with impunity. You don't need to worry about where they're gonna put their bed. We don't care. You can put your bed anywhere you want because the supply is 6 feet up in the air. Now, then there's also a hybrid supply method where we will have perimeter perhaps in the basement, maybe on the main floor, and we'll have a higher wall supply in the second story. So we can choose that supply system. We can choose the velocity of the duct sizing. Now again, this might be something new for some people. This is part of, actually the last slide in this one is actually part of the master planning and decision guide. So what we are doing currently as standard practice in Alberta here is the low velocity ducting. It has worked for years and years and years, and it's worked in many cases based on us oversizing a lot of equipment. But as we get more and more efficient in our homes, the delivery systems may have to change. When we started building energy efficient homes in the mid-2000s, we never had heating complaints or anything like that before. But once we started reducing the heat requirements, we wound up having problems with, I got cold bonus room, right? That used to be the big one because it was the room furthest away from the mechanical room. And it's also the room that has 5 of its 6 facets lose heat somewhere. So it's actually the room that needs the most heat, but it usually gets the least. So one of the solutions is actually changing how our delivery system works. It's not necessarily increasing the size of the furnace, which used to be the way we thought. Let's look at the delivery system and how that works. So low velocity ducting, it operates at around 0.5 inches of static. And it's served us well for as long as we've had indoor heating systems. Going to a mid-velocity system or a high-velocity system, we're reducing the size of the duct, we're increasing the pressure within the duct. And what it does, in a low-velocity system, we have our takeoff, we've got our trunk, our supply, and then we've got the supply going to the room. In a low-velocity system, that first takeoff gets the most air. The second one gets the second most air, and so on and so forth. And usually our bonus room, which is at the very far end, it's getting nothing. Just can't even blow out a birthday candle, right? It's a 90-year-old man blowing out a birthday candle. So what these high velocity and mid velocity systems do is they change the low velocity concept from being velocity to it being pressure. So what we're doing is we're creating pressure in the duct. So what happens is your supply, your trunk, pressurizes. And it works like the old soaker hoses. You know, with all the old soaker hoses, they used to have all those pinholes in them. Those, what they would do is they would fill up, and then all the pinholes would make everything rise. And that's what happens with a mid-velocity and a high-velocity system. It's not exactly self-balancing, but it gives you a much better shot at having a well-balanced system and good delivery, okay? So again, the Master Planning and Decision Guide has more details on this sort of thing, but I'm a big fan. The great thing about mid-velocity, I don't know of any current furnace manufacturer that doesn't allow for that kind of operation. So we don't have to change any equipment. When we get into high velocity, because we're dealing with a high static pressure, we do have to change the equipment a little bit. And it becomes proprietary. The ducting becomes proprietary. Your mid-velocity, you're dealing with 3 and 4 inch metal smooth edge ducting. There's nothing strange about it. We can get it from all of our suppliers. The zoning. Single zone ducting, assign 1 zone per floor, other zoning approaches. These are all things that can be accounted for in the software. Again, one of the advantages of the higher velocity, the mid and the high velocity systems, is these systems, if you do them right, they're very easy to zone. They're very easy to rough in for a zone. We have one mechanical contractor up in our market. What they do everything mid velocity. There's nothing larger than a 6-inch, 8-inch supply coming out of the mechanical room. And what they will have is they will have the main trunk, have the 3 8-inch supplies coming out, and then all you have to do for zoning is just put the controls. So it's zoning rough-in for future proofing. You know, homeowners may not have the money for the controls when they're buying the house, but at some point in time, they can make that investment, and we've already run the ducting for it.
Just on the high velocity, we haven't installed any, but we've done service on them. We service everything we install, but sometimes other people's stuff.
Mm-hmm.
In this case, the 2 that we've dealt with, they've been having issues with a single stage AC when they're zoning.
Freezing up? Yeah. Yeah, that is very common when you get into these things. One of the caveats that I have with the mid-velocity system and all the other stuff that we're about to talk about is none of this should be entertained without a proper mechanical design. Okay? What happens with a lot of the high velocity and the mid-velocity stuff is somebody will come in afterwards and put a single stage AC in there without actually thinking about, oh, this is a high velocity system. I probably have to think about what my CFMs are going to be and how much air is actually really running across that coil.
That was a conversation I had with the customer. So they took the zoning out to keep it from freezing up.
Yeah, yeah. Or, I mean, initially,
Until they can get something that can.
well, until they get in something fully modulating,
Yeah,
and then we don't have any issues, right? But that's a certain lack of knowledge on the person that was installing the AC unit. They were just interested in installing the AC unit, getting that sale, and not actually, that whole good, better, best, that didn't even make it to the good part, right?
So-
You're putting in
so
something that doesn't
what
work.
I'm saying is, it sounds accurate, and the high velocity systems have problems with that. Usually it's A coil, well, it's not, it's a slab coil.
Yeah.
Before the unit.
Yeah. Yeah, so the builder I used to work for, we do everything, we've done everything they do everything high velocity, have since about 2013.
Impressive, they seem to.
They're great little systems. The nice thing about them, again, they use the high wall supplies. We never have to worry about somebody doing that. But there's a cost difference to doing the high velocity stuff. They're because, well, again, you're in proprietary ducting, proprietary mechanical equipment. Whereas with the mid velocity, you're using 3 and 4 inch smooth ducting, and you're using your standard furnace. So there is something to be said for running the mid velocity stuff. Sorry, I missed that. And then going into the zoning system, zoning, as we get more and more into the higher efficiency homes, this is going to become more and more important as well. Particularly with all the stuff that's going on about passive solar heat gain in the code. Yeah, we may have a lot of solar heat gain on the main floor because we got a lot of windows facing a certain direction. Maybe we don't have anything in the basement, and the basement's getting cold, but the main floor is hotter than the hubs of hell. The zoning is going to take care of a lot of that. And it doesn't lend itself so much towards the energy efficiency side. It's more about comfort.
But these high velocity, are they not hydraulic? The ones that I've seen?
Yes.
That's the only ones I've seen.
Yeah, they're combis. Yeah, for the most part, for high velocity. Mid velocity, you can run with just a regular furnace. So if you're a Train, Carrier, Goodman, Daikin, whatever dealer, your furnaces will run a mid velocity system. And then we start talking about select the air duct design. I already know the answer to this question, but I'm going to answer it. I'm going to ask it anyway. I know the answer. So are we currently still running our cold air returns through the framing? Yes?
I think people are.
We hope that there's some kind of cold air running through some kind of framing. That does become a bit of an issue when we start talking about in here the traditional return systems. These actually presume ducted systems. Again, as we move forward in energy efficiency, ducted systems become more and more important. I like to use what I call the tissue test. Go up and do the second story, and I will throw my own house under the bus for this one as well. I can go up into my second story cold air return. I can put a piece of tissue up against that cold air return when the furnace is running full blast, and that tissue just falls to the floor. That cold air return is doing a great job of evacuating air from a joist space somewhere. I don't know where it is, but it sure isn't my second story. So if Dave can stand on his soapbox again for a second, because I have a few HVAC contractors here and builders here, please do consider a fully ducted return system. Now, when you get into this, you can get into simplified return systems where you're not pulling cold air from every single room in the house. There are methodologies for doing that. that can actually minimize the cost. But when the benefit to the homeowner is you're actually getting the air moving. You're not just relying on the natural buoyancy of the air to come up from the main floor into the second floor. You're actually moving some stuff around. Because currently, as I said, in my house, there's nothing moving around. I have a cold air return in the island on my main floor. It still does not pass the tissue test. And it's only 15 feet away from my furnace room. So there's something going on between, yeah, I don't know if, you know, somebody's, you know, some rodent has set up shop in there someplace. I have no idea, but there's very little cold air from where I want it to come from going into my furnace. Okay, duct sealing. This one here is actually where we do a little bit better as an industry. There's base level sealing, which means that we're actually just sealing the supply ducts and not necessarily the branches. The Energy Star, we're actually sealing up everything, including our cold air returns. So we're kind of in between this right now because we're not running fully ducted returns, so we can't seal our returns. But we're somewhere in this right now. We're a little bit better than base level sealing. We're not quite as good as the Energy Star. The last option is sealing to the Energy Star requirements with verification testing, and that's why I brought this little guy over here. This is what we call a duct blaster. Feel free to have a look at it. This is something, it's basically an air pressurization test for your ducting. So if you're doing EnerGuide, you're probably familiar with blower door tests, which are depressurization. In this case, we are sealing up all the ducts, sealing up the cold air returns, and we are pressurizing the systems to measure the amount of air leakage. And let me tell you, on old homes, it is horrifying. We can expect anywhere between 50 and 70% duct leakage on any home built before 2016. Around 2016 was when we started sealing things up better. And because we seal things up better, we're now in the 30 to 50% duct leakage. Okay? So that means that 30 to 50% of the air that we're heating is doing a great job, again, of heating a joist space somewhere. Or a wall cavity somewhere where nobody lives, except maybe a couple of critters for which they are eternally grateful. All right? But, you know, getting to that level, the crazy thing is if you're, you know, again, looking at some builders, that if we're going into the high efficiency homes, this becomes important because our equipment, even though we're running air source heat pumps and we're doing this low and slow, we're not doing it very often because we don't have a whole lot of heat being lost, right? So, you know, we do want to make sure that the heat gets to where it's supposed to go to. So one of the things that we can do is there's a product out called AeroSeal. It is available from some of your mechanical contractors. They use a device just like this. It might actually look a little bit nicer because this is the last iteration of it. And what they do is they inject, and this is a technical term, people, sticky dust into the plenum. And this sticky dust finds all the eddies and all the gaps in your mechanical delivery system and seals them all. There's a couple of benefits. First and most obvious benefit is that you actually get air to where the air is designed to go. The second benefit is you don't have to clean your ducts as often. Dust and dirt collects where there's turbulent flow. And the only reason that we have turbulent flow in ducting is where we have the openings. So this seals all those openings and you go from a turbulent to a laminar flow. So everything flows straight through without any obstruction. The dust goes along with it. So we do have a little bit less requirement for duct cleaning when we do this. Now this is not an inexpensive thing. I don't know, any of my HVAC guys here do it? No? Okay, I was hoping. Yeah, the AeroSeal? It's not inexpensive. But on a higher end home, it's 110% worth it. It's like we're talking a couple of grand. Just to do a blower door test. To do a blower door test on a house, we're only in a home for about an hour. To do a duct test in a home, we're there for the day, because we have to seal everything off. So the costs are, are consumer with that. So they're doing a duct test, and so not only are they doing a duct test, but they're also probably doing your duct testing on your cold air returns as well. So they're sealing those as well. So the time is a little bit longer. There's a product requirement. So yeah, I imagine you're talking a few grand.
Edmonton required ducts to be insulated.
Not anymore.
Do you know, they used to.
Change.
They changed that?
Yeah.
Somebody pushed back?
Yeah, I hated it.
Yeah, we looked at it and it said, "Look, those poor guys are gonna get killed."
No, they did, but it transfers to the homeowner, right? Like
I mean, I'm talking
Yeah.
the
Yeah,
contractors.
Yeah, I mean, at the end of the day, it's the homeowner that pays the freight.
Yeah.
Let's be real about it. So anyways, these are the options that we have in there. So we got the duct sealing, heating and cooling inputs. So this is where we put the inputs from the F280. So down at the bottom, we have the designed heat loss, and we have the designed heat gain, which is your cooling sizing. All right, step 10, unit selection. So this will allow you to select up to 3 different units. Now these can be all the same brand as which we have here. They can be different brands. Now, this uses a database from what's called NEEP, Northeastern Energy Efficiency Partnerships. And what they do is they take data from the American Heating and Refrigeration Institute, and they do it just for heat pumps. And what this will do is it'll give you data for anything that's been tested. So if I have any advice to give anybody on this, is don't try to mix and match too many things. If you have a Carrier exterior unit, please use an interior coil from Carrier as well. The one notable exception is ADP. ADP does have some testing with other manufacturers, but it's kind of a go with God and pray kind of a situation. But if you're sticking with Carrier, Trane, Tassat, Daikin, all the usual suspects, chances are these guys are in the database, and this will give you that good information that you require. So we can filter by brands. As you can see in here, we've got AHRI numbers, and we've got the rated capacities across different temperatures, and we can apply a few filters. So you can browse the large database of options. And then, going back here, you can see we've actually put in a 2-ton unit, a 3-ton, and a 4-ton unit, just for giggles. So we've done what our first example was. We've sized for heating, we've sized for cooling, and then we've kind of oversized just because we want to. Select the backup source. Again, here in the province of Alberta, it is far more likely you're going to have a furnace backup. And insert your utility rates. So we can put in the utility rates for our electricity and for gas, and then our controls. So that control section that we talked about, we can pick what kind of a control scenario we want to deal with. Backup only below the thermal balance point, single point economic cutoff. We have a number of different options that we've already discussed. Dehumidification strategy. Do we really need that in the province of Alberta?
Absolutely.
Dehumidification?
Yes.
Well,
For
AC, sorry, my bad.
in AC. And the AC is going to take care of that. Do we need dehumidification any other time of the year? No. So the dehumidification strategy is, and this is looking for any extra dehumidification that you require.
It's HRV for winter.
Yeah, they're not talking about HRVs. They're actually talking about putting some kind of an actual dehumidifier in. All right.
I find
So
the biggest demand for dehumidification now is when you have slab heating in attached garages, and
Yep.
during 2 vehicles coming in, they're leaking all the snow and stuff
Yep.
off, like a little bathroom fan in there.
oh yeah,
That doesn't
Yeah.
cut it anymore. I think you pretty much need to have some sort of
utility fan.
humidification.
Yeah, you need a utility fan on a humidistat, right? Yeah, I had that same thing in my house. I had a home about 5 homes ago now. Lovely in-slab heating. This is when utilities were really cheap. 24 by 28 garage. You used to pull 2 cars in, and it turned into a sauna because there was absolutely no ventilation in there at all. There's a couple of windows, and if it was cold enough outside, And just be, why is there 3 inches of ice on the windows in the garage? So, and then we're going to what we're going to get is we're going to start getting some outputs. So the greenhouse gas emissions, the cost and the energy use comparison. So again, here we've got our 2, 3, and 4 ton units, and what the different heating consumption and the heating cost and the greenhouse gas emissions associated with that are going to be. Okay? And once we have that, this is where we can have that conversation with the home builder or with the homeowner and say, okay, what are your goals? We've got some data here on the greenhouse gas emissions, on the economics of it, and on the heating and on the absolute energy use. So whirlwind tour, I think we've already discussed all of these things, the smaller ducts and higher velocity simplified return, and the higher wall and air sealing. I would encourage you, if you haven't done so, go to the NRCan website, download that design, master planning and design guide. It's free and has a lot of good information on all 3 of these. Okay, so the impacts of a backup system on the 3 ton. So in black, the app outputs are what you can see in the application. The red are parameters that are calculated in the back end and will be available in future iterations. Okay, but we can see from the air source heat pump with the 3 ton variable unit, we are covering 67% of the heating, or 77% of the heating is above the thermal balance point. And again, like I said earlier, it says 12 here, it's actually 12.8, so some of them said 13. The impacts of the controls, again, when we come out of here, if we have the hybrid 3 ton, we manage to use the air source heat pump 82% of the time, which is a good utilization if you're looking for absolute energy efficiency. Okay, one of the things that we did throw in here just for giggles was what happens if we upsize it just a little bit, and that'll allow us to run a little bit deeper into the colder temperatures, so it reduces your thermal balance point. And actually here we do wind up running this instead of 77 to 81% of the time, but because it's oversized, we do run into that same problem of, oh, do we have enough room on the electrical panel, et cetera, for it, right? So there's a little bit of a dance that you can do here, but my suggestion is, go with the recommendation. Once you start running away from that, you run into some other problems. So recap, we use the app to test the impacts of backup, control, and size. We can use the app for all of that. We can put some numbers to what is often just rule of thumb, which is great. We're not guessing at things. The system selection can work with existing ductwork capacity. So if we have ductwork that we think that's been done in the last number of years, I think where we might run into some difficulty is some of the really old ducting that is leaking 70, 80% and is not properly sized even for AC. That might be a bit of a problem. But we can also use this app to collaborate, and that's where it's really important. I think with builders, when we're trying to build energy efficient homes, it's good to have our builder partners in the room having the conversation before we do the design. Let's have that conversation. We can probably find ways to save money, do this more economically, and at the end of the day, wind up with a better product. So key takeaways for the day. Oh, my time is amazing. Look at that. So heat pumps require special considerations. I think we all agree on that. There's a certain amount of training that's required of the homeowner, a certain amount of training that's required for the people that install it. But better data leads to a better result. Right sizing reduces warranty callbacks, helps avoid extra costs, increases the client satisfaction because we're not short cycling, they're comfortable in all rooms, and builds, like I say, I don't know if it builds a positive reputation, but it keeps you from losing it anyway. The F280 are the foundation. Okay, so if we're doing heat pumps, F280 is absolutely where you want to start, okay, as a minimum. And as a minimum, we want to do that whole house calculation. As if you really want to get into it, the whole home design is a great way to go. I do recommend builders try this once or twice. It can actually have an effect on how you design homes. And we also figured out that the NRCan's sizing tool provides a software engine. It provides useful outputs. It's something that's a great conversation starter, and we can help customers and builders meet their goals with it. There's our link for feedback. If you have any questions, I am happy to answer them, but we are at time.
Are you sending this slideshow out to us?
This slideshow, as Joe mentioned originally, this is being recorded, so this will be available in their resource center.
Yep.
Probably within,
Probably in February we'll have it.
in February, yeah. So they'll have it up. So yes, this will all be available with my dulcet tones over top.
We'll have slides or?
I'm gonna
just the
ask,
video?
I'm gonna see if I can also get the slides provided.
help.
I just have to check with the LEEP program if they're
Yeah.
comfortable with me posting them.
Okay. Anything else? Okay, good.